through the zeolite tank, and it causes regeneration of the zeolite. So in this manner we have two cycles of softening and regeneration of zeolite again and again till the softening occurs. As you can see in this picture here, this cycle is of softening. Hard water consisting chloride or sulfate is made to pass through Na2Ze. Na2Ze has got converted into corresponding zeolite, and water has got converted into softened water. Here M is nothing but calcium, magnesium or any other hardness causing salt. Now the zeolite is completely exhausted. So what we need to do? We need to pass brine solution, that is Na plus and Cl minus, to MZe, that is exhausted zeolite. It's get converted back into Na2Ze, that is regenerated zeolite, again can be used for the softening purpose, and wastewater is generated. This is the regeneration cycle, and these softening and regeneration cycle occurs again and again. We can show the regeneration reaction like this. Softening reaction, now these are the salts from hard water. This is zeolite. Water gets soft. Now regeneration of zeolite, CaZe plus 2Na plus, which is coming from brine. It gives us Na2Ze back. This is regenerated zeolite plus Ca2 plus, which goes in wastewater. So in this manner the whole this is softening and regeneration cycle occurs. Now let us see advantages and disadvantages of zeolite process. It removes almost complete hardness and produces water up to 10 ppm hardness. See, this is advantageous over lime soda process, because in lime soda process the residual hardness, means hardness remaining after softening process, was 15 to 50 ppm, while here the residual hardness is 10 ppm. So it is better than that. No sludge formation occur. Again, this is the parameter which is better about lime soda process. In lime soda process lot amount of sludge was generated, and there was a big problem of the disposal of the sludge. Here there is no sludge is produced, and there is no problem of the disposal at all. Besides that, the method is cheap, since zeolite can be reused. As we have seen the regeneration of zeolite, so its maintenance cost is less. As we have seen earlier in the lime soda process, maintenance cost was very high, but here the maintenance cost is less. Again and again we can regenerate the zeolite and we can reuse it. Now its disadvantages: the treated water contains more sodium salt. Whatever the hardness causing salt was present in the water, when it is passed through the zeolite, double amount of sodium salts are generated, because for any bivalent cation 2 moles of monovalent sodium are given. So if 1 mole of calcium sulfate is present, we will get 2 mole of sodium sulfate. For 1 mole of calcium bicarbonate, 2 moles of sodium bicarbonate will be generated. So the hardness causing salts are removed, but double the amount of sodium salts are generated in the water, and water becomes very salty. Though the sodium salts are not causing hardness, but the sodium salt concentration increases in the water. The water is not useful for treatment of turbid water. As we have seen that zeolite are a complex structure. They are this honeycomb like three-dimensional structure. So whenever turbidity is present in the water, then this turbidity may clog the pores of zeolite, and hence zeolite cannot be used for further softening process. So if the turbid water is there, we need to make sure to remove the turbidity prior to softening. Otherwise zeolite softening will not occur at all and zeolite would be wasted. So turbid water, a strict no-no. And acidic water also, it is not able to remove acidic ions and it cannot be used for the acidic water. Turbid water and acidic water, zeolite process cannot be used. And this is capable only for replacing calcium and magnesium ions. These all are the disadvantages of zeolite process, but above all it is better than lime soda process in terms of residual hardness, as it gives us water with the residual hardness of 10 ppm, which is not the case of LS process. But still, for boiler feed we can't make use of zeolite process also. We need some better option, and the better option is ion exchange method. Let us see. Ion exchange process or demineralization process. Now the ion exchange process consists some ion exchange resins. These resins are actually macromolecules or polymers, these polymeric chains. About this, some fixed resin functional groups are attached as shown in this picture. These are the groups, ionic groups attached with the polymeric chain, and these are consisting exchangeable counter ions. This is the basic principle of ion exchange process. As the name indicates, it exchanges its ion. Now let us see what are these polymers and how these polymers are formed. Ion exchange resins are insoluble cross-linked long chain organic polymers which possess microporous structure, and the functional group attached to the polymeric chain is responsible for the exchange of ion. This is the figure showing. This is the ion exchange resin and these are exchangeable ionic group H+. When any ion is made to pass through them, it gives its H+ ion and in turn takes Na+ ion. Here you can see H+ is replaced by Na+. How these ion exchange resins are formed? These are formed by polymerization reaction as shown over here. Styrene reacts with divinyl benzene and this long chain cross-linked polymeric chain is formed. On this polymeric chain, these groups are introduced by chemical modification. These are actually the groups responsible for exchange of ions. These are the groups. And to make, this was the cation exchanger resin, and to make anion exchanger resin, some basic groups are introduced as shown in the picture. So two types of resins are there, cation exchanger resin and anion exchanger resin. And these resin consisting acidic group, they give their H+ ion to the hardness causing salt and take their cations, while the resin consisting basic group exchange their OH- ion with the hardness causing salts. This is the assembly. To make it more clear, here you can see this is, the first chamber is of cation exchanger resin and the second chamber is of anion exchanger resin. Hard water is sprinkled down and it passes through cation exchanger resin. The exchange of ion occurs and what we get is, then it is made to pass through anion exchanger resin. Again here exchange of anion occurs and finally we get the absolute deionized water or the soft water. Now, these ion exchanger resins, these are the reactions occurring at cation exchanger resin, and these are the reactions occurring at anion exchanger resin. And at the end of process, hard water consists H plus and OH minus ion, absolutely. Now, once the ion exchange resin is used, it is again regenerated by passing cation exchanger resin can be regenerated by acidic solution, and anion exchanger resin can be regenerated by passing basic solution. This is the regeneration reaction that you can see. Cation exchange resin can be regenerated by passing dilute HCl or H2SO4, and anion exchanger resin can be regenerated by passing dilute NaOH. So this is very advantageous as it can use to soften highly acidic or alkaline water. The residual hardness is 1 to 2 ppm. So the treated water by this method can be used in boilers. These are the advantages and disadvantages of this method written. It gives zero hardness or absolute demineralized water. Maintenance cost is less. No sludge is generated. Again, benefit over LS process. No requirement of skilled person. It is easy to operate and it can be used for any type of water. As well as its capital cost is more. This is the disadvantage. Ion exchanger resin are quite costly. Turbid water can't be softened. Cost of equipment is very high and expensive chemicals are required. So these were 3 methods of softening of water. This is all for today, and in the next class we'll be talking something about brackish water and breakpoint chlorination. Till then, you just keep revising all these 3 processes, keep doing the numericals based on LS process, and just try to understand the principle of all the processes. Goodbye.